this. So I'm going to start with a simple example of an application uh, and try to give you a context of what is the complexity we are actually need to deal with in the software development life cycle these days, and then what is the need for DevOps to tackle the complexity is what the agenda I'll go ahead with. So probably everybody is aware of e-commerce. You would have done some sort of e-commerce through Amazon or Flipkart in India, or any other ride-hailing apps like Uber or Ola, or you could have used any food ordering apps like Swiggy or Zomato. So most of them, you end up using those applications through either an app installed on mobile device, or you have a browser based URL you hit through to get to the services, and you get the desired functionality what you want from these providers, right? So for every service, what we typically see these days, you need to register yourself as a user. So to you as an end user, you're just consuming a service. But with the service provider like Flipkart or Amazon, need to build their applications in a manner where there is a division of the work based on the domain that is serving the end user of a different service, right? So if an end user want to register, typically you would have a service or list of services which is predominantly helps you to do the registration of a user, set your profile information like what is the address you want the goods to be delivered, what is the default address, what are the different types of address, what is our communication methodologies, phone numbers, all of that you typically provide in this service. And when you log in, you need to manage a session, which basically kind of views the thread of what you are doing at the in a e-commerce website, and then you browse the items, and you typically see a cart where you include your probable choices to purchase to the cart, and then finally you keep changing the quantity or remove the items from the cart. You need an area or a service within the entire gamut of things to manage your items in the cart, and then you obviously need to purchase. For that you need to finish the payment. So there has to be payment service which is dealing with those options. And to explore or to discover products, you need a search engine, and you would typically see some sort of ads. Once you visit an e-commerce site, when you go into any of your social profiles like Instagram or Facebook, you typically get to see the items what you searched or what you viewed or what you added to the cart gets shown as ads in your public, basically the social profiles like Instagram or Facebook, right? So that's how typically I've not listed all the domains when it comes to e-commerce, but I've taken a fewer examples which basically you can connect with. But this is a way typically the service provider like Flipkart or Amazon would break down their functionality into smaller functional chunks, and you build these applications. And if you look at in this diagram, a user is talking to a database which is I've listed here as a Postgres, which kind of talks about it's a relational database. There is session management and cart, and for ads I've used a representation of a Mongo database, which is NoSQL, and it's called a document database. And whereas for search, you would have seen we talk about Elasticsearch, which is also a NoSQL database. And payment, I've used a symbol for MySQL, which is a relational database again, right? So when you look at these applications, so they might be using heterogeneous database types and to solve a different purpose. So payment might need transaction support. That's why in this example, I've depicted it as using a relational systems, whereas cart and session, they don't need a transaction consistency. That's why people typically use NoSQL when there is a high scale requirement for that application, right? That way, you would see when you enter into the industry, you would get exposed to multiple different types of data stores. They're solving different problems. uh, solving different problems. Yeah, and then you would need to learn how to manage them as well. But when it comes to the end user, they don't need to, or they don't need to interact with all these applications one by one. There has to be an encapsulation layer, which we typically call it as API gateway. So this kind of ensures, based on what our user is intended to do, it will internally route it to the different applications. So for an end user, you still type it as www.amazon.com or a flipkart.com. And then whatever you say slash cart will go hit here. If you want to change your profile slash user and slash profile, internally the API gateway will go here. So the access entry is controlled to the same domain called either Flipkart or Amazon or any other website you typically end up accessing. And then internally the application would interact with each other. Right? So the last concept I want to introduce you to the content here is, typically when you look at your applications, this is typically called a three-tier architecture. What you have seen is a client and a backend service and your data tier. Typically, when you build these applications, they are stateless in nature. Means user service doesn't host any information about the user. All the information is stored in the database. Whenever user requests to change or add a new address, the application will go to the database to retrieve it to show the results. And you can add one more address, or you can delete existing address, or you can add information to the existing address, all of that by editing. So all the operations will be provided, but the state is always going to be written to the database. And then this session, this information, this application doesn't keep any information in the its cache. That's why this typically they are called stateless applications. Why do we need to make this stateless? It provides you a flexibility that the first request for user can go to this application instance, second request can go to any other instance to support the scalability. Whereas when you look at the data plane, it needs a state. So this has to be holding the state. That's what typically you would see the application being built in most of the e-commerce or any service you typically end up building, which has a B2C business to customer. So we are the end customers. So we are retail customers, what typically people call. We are not a business. We are individuals interacting with an organization. Could be Amazon, could be Flipkart, or could be Uber, could be Ola, any one of them. So in these typical interactions of B2C, you would see the application being developed in a manner where they are broken down into smaller chunks. Each chunk will have its own data access. So these are referred typically in the industry as microservices, right? For the end user, you are providing a service for ordering something, but that is a service. But the service is divided into a micro services. Each microservice handles a specific area in the whole business problem. Let me take a pause here and see if I have any questions on the chat. If you want to type, please go ahead. Yeah, I see a couple of hands raised. Aishwarya? Okay, so moving on to the next. I don't see any questions. So what happens if you, there are a couple of other areas I wanted to kind of introduce you to as a concept before we go into the other areas. You typically see two terminologies that is being talked about in the industry. One is called horizontal scaling of your applications. Other is called vertical scaling of your applications. To give a brief introduction about these concepts, if you remember what I talked about in this slide, these services are typically called, are actually built in a way they're stateless in nature. Um, so that means you don't need to keep one instance specific to one user. So this can handle many users in parallel. So these are typically candidates for uh, horizontal scale. So if a single instance of an application can serve 20 user traffic, as an example I've given, if your application needs scale to support 100 users concurrently, you can run 5 instances of the same application. In this configuration, right? So you typically keep the application configuration with, let's take a 2 CPU or a 1 CPU or 5 CPUs, 10 CPUs, and with a given memory of like 10 GB or 100 GB, whatever you give it to support each instance based on the type of functionality it supports. Whereas databases or caching systems, all of these, since they need to manage cache, you typically go for a vertical scale. What I mean to say is, when you have a lesser traffic during the day, during the night, you might run the database with 10 CPUs, and when you have high traffic period in the morning, you might scale it up to 20 CPUs or 30 CPUs to support additional queries, which could be reads, writes, and right. So when it comes to when you have growing number of users, which is typically what you see on most of the e-commerce websites, right? So there are times where you go and purchase new items which are just launched. Could be iPhone, could be an Android phone, right? So it could be any new clothing, or it could be any shoe. All of them can actually be purchased. But when there is a high demand for a specific product, you would typically end up having many people visit these websites at a given point in time and try to purchase the limited amount of quantity available. So when iPhone or an Android like OnePlus or Samsung launches, they don't have infinite inventory for a specific country, right? So they do release a certain quantities of phones. So it becomes like a war between multiple customers trying to buy the same was very smaller quantity, which is available for purchase on the initial pre-launch or during the launch period. But once the production scales up on this manufacturer's side, you would see that availability of quantity will be more than the people who are interested in buying that quantity. So when it comes to that use cases, that is what typically you would end up seeing. Even whatever thing happened on Sunday, when the cricket match happened between India and New Zealand, Championship Trophy finals, I have got multiple messages from Zomato, Swiggy, as well as from Pizza Hut, Domino's, all of these, which are typically the choices what you end up using, or the local restaurants what you end up using for food ordering on a daily basis or once in a while basis. They reach out to you to say that I have promotions running, and they know that there's a time where somebody doesn't want to move from their couch and still keep watching the cricket match. In those scenarios, they send out ads to you to get your attention and probably convert you as a customer who is going to make a purchase during that period, though you are not intended to buy, right? So those are the typical cases you would see where you end up needing your systems to scale to a higher number of concurrent users or a concurrent traffic that need to be supported. And when the order gets placed, the fulfillment has to also happen, right? So that is going to be delivering the order to you. That is what fulfillment means, right? So all of those cases need to be handled when it comes to uh, peak traffic periods. So in those cases, your API gateway, which is acting as a front-facing system to the clients from the backend applications, you would end up running not one instance of a gateway, probably multiple instances of gateway, so that each instance can support 100 users or 200 users of concurrent in nature. And this is typically called the horizontal scale. So you might be running with one server on a normal day. The peak promotion day, with this anticipation of more concurrent users, you might end up running 3 or 4 or 5 or 10. This is typically called the horizontal scale. And similarly, since all of these applications, we by default built them as stateless applications, this also can be horizontally scaled to support the high concurrent users, right? And you would need a load balancer. API gateway hits a load balancer, which balances the load between these three instances of the same application, right? When somebody wants to newly register or somebody is trying to log in, a lot of people are trying to log in at the same time. A lot of people are adding to the cart the same items or similar items. So that way you end up doing the scaling of each of these service to support your need of your business, right? But when it comes to the databases, as I explained, since these are managing states, not all of these databases do support horizontal scaling. So you end up typically doing a vertical scale. So let me introduce to you a couple of more concepts in this example. The databases like SQL, Postgres, and MySQL typically doesn't support a horizontal scale. You end up only doing a vertical scale for write transaction support, but you can set up a read replica. That means you need to copy the entire data into another instance, and you can send the read traffic to it, right? Read traffic to that, and those can help in a little bit of horizontal scale. And the same thing applies for Mongo and Elasticsearch as well. But if you're intended to do a data model change, Elastic and Mongo support something called a sharding. You can shard the data into smaller chunks and have many servers, the one server handling one specific shard alone. That way you can even do the horizontal scale. You don't need to vertically scale as well. But when you create the shard, that requires a little bit of data movement, and it takes time. If you are not intended to do the sharding, you typically do vertical scale. Otherwise, you can resort to the fact that you shard the data and you spread the data to a smaller servers, but many servers. So that is a choice you make, whether you want to run with larger number of shards and horizontal scale, or one shard with vertical scaling. But the sharding decision is made based on the type of the queries and the type of the data you're managing. It's not always true that you can do a vertical scale alone or you can do a horizontal scale alone. You need to apply the combination of both when it comes to NoSQL databases. But whereas SQL databases, the scaling remains to be predominantly vertical scaling, but you can do a horizontal scale for read operations alone. Okay, so let me take a pause here and see if there are any questions. Guys, microphone is disabled for you guys. Can you please type the questions on this chat window? Senthu? Senthu and Sneha, can you please type your questions? I think give it a few minutes. Okay, so since you guys now got the context of, so here I've given like 5-6 applications, which are what microservices are here, the terminology wise, and their corresponding database of 3 or 4 different flavors of databases in this pictorial diagram. But when it comes to the real life, you might end up seeing a Amazon kind of a system or a Flipkart kind of a system running with upwards of 500 to 600 different microservices, performing different activities in the whole business problem. And each one of these microservices need to be responding to either user calls or internal calls between payment to card, card to payment within a sub-milliseconds. So that means the complexity of the system, what you would be working with, being a developer, being a DevOps person, or being a quality assurance person, is going to be challenging for you to understand the dependencies. When you understand the dependencies, it becomes easy to kind of get through the next stage of your evolution. So keeping that into the context, when it comes to the DevOps, so DevOps typically focuses on 2 or 3 or 4 areas, what I'm going to cover in this next hour and a half. But there are other areas in which you can actually explore in the DevOps as well. If you look at from a complexity of the application, if you look at from the way the need of horizontal scale or a vertical scale of the application, when a developer finishes their functional implementation of the code, taking that to validations in a QA, a lower environment, like a QA and staging, and then finally taking it to production, needs a consistent or an automated process, which is what typically makes you more agile when it comes to picking up any major features and deploying them into production. That's why you end up automating a lot of these processes from a delivery perspective. So that's where the DevOps plays a role. What is it going to, when you do an automation, what is it going to help? It's going to help the speed, and it's going to help the quality of the release to make sure that you don't deliver buggy code to production. That means you have not lost a customer because you have a bug in the system where they cannot pay after you add items to the cart. That leads to loss of business. Right? So all of those things are very much necessary when you are deploying continuously into production. The quality of the system matters, reliability. If you write a code which is basically buggy, or have a design that you use which is not going to scale, that is going to make your system suffer, and which in turn causes upstream or downstream application services also to suffer, and which ultimately hits your reliability of your application. And then if your write doesn't follow best practices, you might leak information about yours. You can log in with one person A and then get the information about address B's, person B's address or the password details, or you get to see somebody else's card or somebody else's order. Once they're placed, you can ask them to deliver to your address. All of those actually can lead to a loss of business as well, whereas I paid for the order and somebody else got the delivery. So all of those things are very much necessary, where you need to kind of ensure that the system have the highest quality and reliability of deployment, and scale and security aspect of it is also taken care, right? So you have to make sure that you have to automate testing as well as the deployment and post-deployment activities as well, right? So this is a terminology what you get to hear in the industry. One is called continuous integration. What the areas it covers is what I'm going to be talking in the next slides. And the continuous delivery and continuous deployment. It's also called CD. Microservice architecture I just explained with a couple of examples. And infrastructure as a code. When you need to horizontally scale, you need to provision new servers to deploy your application code. How do you write the infrastructure as a code? And when the application is running, you leave the traces of how the functional flow has been working. If there are any problems or exceptions or errors you encounter with third-party integrations, you have to log and then use them for debugging and fixing the problems and monitoring your application health. And if it needs more power of CPUs or memory, you bring up another instance of the same application if you are monitoring very closely, so that the customer doesn't face issues with your application not performing when they really need it. And you collaborate with all the stakeholders, which could be dev, QA, and your deployment engineers and everybody, right? And the communication between different set of people is what really this DevOps principles typically work with. And financial prudence, right? So you cannot have infinite resources, but how do you manage your scale, your business needs with a financial prudence? Then only the system is going to be running with reliability, scale, and the quality is going to be utmost important as well, right? Who came up with the concept of DevOps first? That's typically when the industry starts getting into more and more complex when it comes to the functional implementation of it. You start seeing new roles being formed, new roles being coined into the system. So Google and these systems, when they started running with thousands of servers for your search support and all of that, that's when the DevOps as a concept has come into the picture. So in next set of slides, I would be covering CI and delivery and deployment aspect of it, and I'll give an introduction about what is logging monitoring aspect of it, what roles typically play in this area in the next set of slides, and what are the career options you would have as a person is what really I'm going to be focusing next. So when you search on the internet, you typically get to see this is what really a diagram which you would typically get to see quite a lot when you do a simple search on the DevOps aspect of it, right? So you typically plan a functional release, the functional aspect of a problem, and then you code, and after that you build and you test it. Once you tested everything is working, this is typically the development cycle of your application or any microservice or a functionality. After you tested it, you release it to different environments to test. So this is where the operations work will start from the DevOps aspect of it. And then you deploy the code and you operate the code and you monitor the performance of your system on different environments, and then ensure that your quality is met, right? So when it comes to the CI aspect of it, so this is a concept you would have learned in your software development lifecycle course, right? So this is typically has an acronym of SDLC, software development lifecycle. So in this, you would go through multiple phases of your application. So when it comes to DevOps principles, the requirement gathering, system design, which is microservice architecture, what you want to come up with, and application programming interface, typically referred as API. So API has a standard structure in terms of what is the input you would give to the application, and the functionality it goes through with a lot of computation, talking to different services, different data stores, and finally collecting the data and responding back to the user with a response is typically you would define an interface with upstream, which could be the client, a mobile, or a web application, or a different service which is consuming your services also. You define an interface that this is the way you give the input to me. This is the way I respond back. If the functionality works fine, if there is a problem with the validations, I will respond back with this error message, is what typically you define in the application programming interface. So why am I emphasizing all of this is when it comes to monitoring of the system, you as a DevOps engineer need to build the framework to monitor the API request and response, right? The response you're getting is always error. That means there is some problem and you need to alert the user. That's why you, as an engineer, though you don't develop the actual code behind the API, but we as a DevOps engineers need to understand the API response types and requests which are coming in, so that we can put in proper monitoring and alerts, right? So on the system wise. And then the development process typically involves developing your classes, in Java or Go or any other language like Python, but you need to commit this code into a source repository, and that repository we should support different branching strategies. Uh, how do you build the code that is committed, and all of those things is what typically you would end up seeing in the continuous integration phase. And then each developer is asked to do something called a white box testing. Why is it important is you might write code in a fashion which involves a lot of if-else conditions, a lot of iterations of data what you're retrieving from the database or from a different service, downstream calls, all of them. So you would ensure that if a property of a field becomes null, how do you handle that error messages? Everything you test at a unit level, and that's what typically is called white box testing, and you need to do that on a regular basis and repeatedly, right, for every code change. This also helps in integration, and the unit testing also helps in if you automate the testing once. If somebody else modifies the code, they are assured of not breaking the functionality which is supported thus far. Whatever the additional changes the new developer is making on existing code, they need to develop additional test cases on top of what is already in place, so that the baton is passed on to the next developer. When they make the code changes, they are ensured that they are also confident that I am not going to break the existing code functionality. That is why right now most of the SDLC process mandate, not give a choice, but mandate development of unit testing and integration testing on every service what you develop. And some people have, so if I look at most of you, when you start learning your programming concepts, you would end up using very no standards for naming even the variables. We end up doing like integer I or integer j, whatever it is, and then string s, right? So character c. When it comes to deal with 500, 600 microservices, and each service having an umpteen number of functional APIs to support, and a lot of functionality that is supported, having a variable naming convention like IJK will make it very hard for any developer to understand the concept of the code or the functionality that application or that method is supporting, right? The best practice is what you need to follow. Typically, every company adopts to certain standards of naming convention, and the Java community itself has, and Spring or any other framework what when you adopt, each of the community has come up with some best practices to follow, so that when you walk through the code or when you're reading somebody else's code to add new functionality on top of it, it becomes easy for you to understand those existing code bases, right? So you need to have a system which is enforcing the best practices which need to be followed. If somebody names the variable as I, the build should fail. So if you want to define those, they are not functionally wrong, but they make the code look ugly. They make code look very difficult to understand as well. So that is why you need to have a system which is enforcing these best practices as well. Scanning for security vulnerabilities. So if you follow certain patterns of coding, just to give an example, if you're taking an input from user and you append that to a query directly without doing a sanitization of the data, user might give percentage. When you write the query, when you say select star from this table where like when you say percentage, funny percentage, that means it will give you all users which are not which are also starting their name with funny, right? It could be like thousands of users information. You give it to the end user without, you should not be giving it. That is basically leads to security vulnerability, where you see a lot of these hackers trying to reach to your application APIs, send different types of data to guess if your database is Postgres or a SQL database like MySQL, percentage is used for matching substring, right? Percentage funny, percentage, you can give it, right? So it will give you all the users which are matching with these percentages. Somewhere you need to verify that following a practice of a code that leads to secure vulnerabilities based on whatever is known and already attackers were using it in the past. So there has to be a system which is enforcing the security, vulnerability scanning as well. And data model management, you have database with multiple tables, multiple indexes, multiple constraints defined. You need to have a system which manages the data model as well. And you have to have, once the code is built, what you developed, unit tested, and integration tested is done, everything is fine. You need to take this artifact, which is predominantly a Java artifact like jar or var, and that you need to deploy across multiple instances of your lower environments like quality assurance, pre-production, and production systems. So when it comes to DevOps, actual automation aspect of it, we would provide in the continuous integration phase, you need to have a mechanism to support committing the code. So typically most of the organizations will have a division which basically looks after managing the source repository, and you would end up DevOps supporting a frameworks to, or the systems which basically they can run unit testing and integration testing, because unit testing you can run it on your local, but when it comes to integration testing where you are interacting with thousands of microservices or hundreds of microservices, you cannot set up all of them on your local. That's why you need to have an environment, or you need to have a mechanism to do the integration testing. This is what typically CI process expects, right? And when it comes to the DevOps engineer, some companies call them as build engineers or the continuous integration engineers as well. So you get to hear this terminology in different organizations. So they only focus on enforcing these or building the tools, which helps thousands of developers working with the organization to develop the core functional aspect of your application. Yeah. Let me take a pause here and see if there are any questions you want to type on chat. Yeah, so I hope this is clear. So when it comes to, I'm not listing all the tools you typically you get to see in the industry. So you would see something like a Terraform as an example. If you want to set up a new server, if you want to set up a new database instance, if you want to set up a new application instance, a new API gateway instance, Terraform is one of the predominantly used open source tool, and there is an they've become now a closed source tool. That means you need to pay licenses for it. So there is something called OpenTofu, is another tool which basically supports this infrastructure provisioning as a system. So why do you need to do? Why do you need to be understanding this Terraform, right? Today, when you look at your application, you might end up using the cloud providers like Google cloud providing system like GCP, or you would have heard about Azure from Microsoft, or Amazon AWS, which is Amazon application web services, right? So, or it could be a local providers you would find in different countries, or you might end up deploying your applications on your own managed servers running on your on-premise, or a co-located instances, right? Co-located data centers, right? So having said that, your application developer doesn't need to know where the application is getting deployed. They just need to understand that this is the way we end up deploying the application. But from a CI engineer or a CD engineer, we need to provide resources to them in a way where they could actually perform their duty of continuous integration, which is for unit testing and development aspect of it. That's why Terraform provides that encapsulation of infrastructure creation, irrespective of the cloud provider or irrespective of the your own on-premise or a local player you're dealing with, right? So this is how the industry is moving towards these days, right? So you would see some automation tools, some of these tools coming up. They encapsulate, they abstract out the entire complexity of underneath calling thousands of web services, API calls to provision a server in AWS or at GCP. So you write the code in a same manner where you specify that my need is to set up a server with 2 CPUs and 8 GB RAM or 10 GB RAM, and that's it. The same code would run on any of the cloud providers. That's why when you are a CI engineer, CD engineer, you need to figure out the tools which actually helps you to migrate away from one cloud instance or other cloud instance for cost reasons, which is what I was talking about, financial prudence in one of the previous points, right? So you would get exposed to these sort of tools when it comes to infrastructure provisioning, when you get into this area. And then Jenkins is one popular tool, and there are something like Argo CD are the tools available. They also help you to build your application, which is either developed in Java, Go, or Python. Why do you need to do that on a build server versus a local server? The reason for that is I might be running with a Java 8.1 version. My friend might be running with Java 8.9 version. Somebody may be running Java 11 version. So if we allow developers to build on their local and push the code onto production, there is no consistency of the Java version or the Spring Boot versions that are being used, right? So anything which is managed in the Bitbucket or code-based perspective, where Jenkins will provide that consistency of building with a specific Java version, which is going to be deploying in from lower environment like QA to staging to production, right? So Jenkins is a very extendable tool. You can write code in Jenkins. It provides some flexibility to write your own pipeline, where you download the code from the source repository, you build the system, you run the unit test cases, you run the automation test cases after that, and you go through the Sonar Cube, which is predominantly used for your best practice enforcement tool, which could be for security purpose, which could be for your best practices coding perspective. All of these activities which need to be done. So they're going to be differing from company to company, right? So the tools could be different, what Bitbucket versus GitHub you're using. So Jenkins provide a mechanism for you to define your own pipeline, and whether you want the pipeline to be running sequentially or pipeline to be running in a parallel manner, and finally do the generate the artifact which you would be deploying into your environment, right? So basically artifact registry typically keeps your var or a jar or any other binary active artifact which is built after compiling your Java or Go or Python code. When you do this activity of artifact creation, that ensures that the artifact is built with the same version of a Go or a Python or a Java. But when you have to deploy this in a server, the server need to have the same version of Java or a Go or a Python version what you built your application with. That again is a problem if you don't manage your CD part, deployment part very well. So these days what industry is moving towards is to create a Docker image of your application binary, which is also embedded with a lightweight container OS. That container OS will contain the Java version what you built your application with, or a Python version what you built your application with, or a Go, anything, right? So any other language. And it has a required software already pre-baked in along with your application to run. So now this Docker container you can actually deploy in any of the environments, and it is going to run with exactly the same version of OS, version of tools or the dependencies or plugins what you made, right? That way, between environments when you're deploying, you don't need to spend additional headache of verifying the uh, consistency of your versions, right? So when you dig more into these aspects, when you go into different companies, you would see a lot of emphasis as being put on CI, where the builds have to be uh, much faster and the build output should be done with quality. Once you ensure the quality at the early stage of the application build, you would encounter very less problems when it goes to production, right? Uh, why the emphasis comes here is people typically measure from the time you commit your code to the Bitbucket, how quickly the same code can get deployed into production as a measure in most of the companies uh, to see whether your CI/CD pipeline is mature enough or not, right? So that's why a lot of companies I see you would end up working with might be doing deployments, thousands of deployments in a day, right? So for that, you need to have a very solid foundation in the continuous integration and the tools what you're using in this continuous integration phase as well, right? So I hope that is basically gives you a good gist of tools. So you will end up picking up one of these tools or many of these tools or the equivalent of these tools in when you actually get into the CI area. So when it comes to the CD, before we go to CD, let me pause for a minute or two. Okay, I think let me go into the CD part of it. So CD is basically what is deployment process, right? So you built your artifact. Now I need to deploy this artifact into a different environment. So let's take an example of a production. I need to deploy same application to with one instance of running or 10 instances running. So for that to happen, CD need to have a mechanism to do the infrastructure provisioning, the server provisioning for deploying your application. And then you deploy the application with your Java container or the Docker container, whatever you want to build it as, right? So, and then this application with a load balancer, because you are not going to run a single instance to support high load traffic. You need to register that with the load balancer. Horizontal vertical scaling. Your application might be running on a night with one instance, but when it comes to the peak period, you might run with 5 instances, 6 instances. This whole thing need to be automated or automatically supported by the underlying framework what you are building for your infrastructure provisioning, right? So all of that is a part of your CD duties. Data management, because the data, if you have more number of users registering with your website, more orders coming into your application, to your website or to your app, your data starts growing. How do you effectively manage the data is what you end up looking at in the CD part as well. As I mentioned in the couple of examples that you need to have the logging in the system so that you can look at the flow of your application. And if there are problems encountered, you need to debug. That is one. Another thing is you typically log the data for audit reasons as well to debug from any security vulnerabilities aspect of it. And you need to have a mechanism to monitor health of your application. You need to alert for any faults that is happening in the system. That is what really the deployment aspect of it covers. And once you have the data, you need to manage the backups because you might, the servers what you're running your application with, they're not 100% reliable. There would be situations where you encounter hardware failures or application, database itself is an application, you might see them running into some bugs here and there. So in those cases, you would need to restore your data from the backups. That's why you typically end up keeping your database backups or any other system backups so that you can restore things faster if there is any hardware failure or software failure in the application wise. And then your deployment process also need to have information provision to protect from the non-state actors. When I talk about non-state actors, means let's take your application can support 10 concurrent users. If you need to protect your application from beyond this, what you can actually support your application with, you need to have a mechanism, something called a rate limiting. Why does rate limiting important? If, to give an example, if a competition of your service wants to make your service not accessible during a big match like what happened on Sunday. So I'm not saying that if Swiggy and Zomato will do it, but I'm taking them as an example. So Swiggy can actually run a DDoS attack on Zomato or vice versa. It could be somebody else wants to bring down both the services because they don't wanted these services to be running with users taking order data. So they might run something called a denial of service. Denial of a service. That's typically referred as DDoS attacks, and they can actually do that activity on your application. That's why when you are building your application, you need to think about all of these aspects, and you need to protect your system from something like a denial of service. Everyone that those kind of aspects need to be thought through in the continuous deploy and continuous delivery aspect of your application. Yeah. Similar to the tools what I have listed, you would see Terraform again for the CI and CD. The infrastructure provisioning would remain the same. Or probably in the production you might see it with a higher CPU memory configuration stand when you are doing in a simple test environment in the integration phase as well. But Jenkins also helps in deployment application, not only build of your application. Or you can see Argo CD or some other tools come up here as well. I'm talking predominantly on the open source tools, right? So Kibana is one of the well-known, or Loki is another tool you get to see, and Cognos. There are multiple tools in this area where you can manage your logs. So logs is basically you have to collect logs from all these hundreds of thousands of microservices that service deploys, and you need to have a mechanism to get to the searching of the logs when you have terabytes of data, right? When you look at any, let's take an example of Hotstar, right? So when the match was happening, I've seen the ticker saying that 65 crore people are accessing the streaming at any given point in time. If Hotstar wants to debug a problem where some lot of users are not able to stream the content properly, they would be collecting the information through logs. That logs would run into terabytes of data per hour or per minute. You need to have a tooling system which actually helps you to query those terabytes of data to identify the problem quickly, so that the money I'm paying for Jio Hotstar, I'm not going to get a poor service, because otherwise I would never subscribe with a Jio Hotstar. I would end up doing with some other provider for it, right? So these are the reasons why this is very important to have your logging system built in a manner where you can collect a lot of data and provide an easy mechanism to get to the problems and search into the logs very quickly, right? And then Prometheus is one of the system, which is again open source tool. It provides a lot of plugins to collect metrics across multiple types of applications. So example I have given, like a Java app, Python app, or Go app, or you have a database running like Postgres, Mongo, or even your MySQL, right? Elasticsearch. Prometheus, since it is being open source, a lot of people have contributed to write plugins to collect different metrics from all of these types of applications and push them to a Prometheus system, which basically stores the data in a time series fashion. And it allows you to query the content from this system, and you can actually configure alert conditions or thresholds based on the current monitors, right? So just to give an example, if CPU utilization in the server goes beyond 80%, you send a warning message, warning alert, right? If it goes to 90%, you send a high priority alert. If it goes to 95%, send a critical alert, right? That those kind of conditions, if you want to keep in, you can actually configure them in these monitoring systems like Prometheus. Or if an application API is taking more time, but your system CPU is 100%, not even 100%, is on 50%. But API is taking more time. This could be because you are interacting with the downstream system. Let's take when you're paying through Google Pay or through any payment system. So sometimes you see a slowness because the downstream bank is taking time, where your GPay or PhonePe is interacting with, right? So those cases you would need to get an alert to say, I need to interact with HDFC or ICICI or any other banking gateway to tell them I'm seeing slowness from your service. Can you please also ensure your service is scaled up, right? So those kind of things is what really monitoring systems will allow you. It's not always that your problem is on your side. It could be problem on the downstream systems also, where you monitor the external calls or your application calls, so that you can alert when it is needed. So PagerDuty and GenDuty, there are again OpenSeas, a lot of tools come into this area. So they help you to alert the required set of people. So when you are in a team of 5 to 10 people, it's not true that every day, all through the year, you will need to just page one person. There might be a rotation which is going to happen within the team. So today I might be on support because my services, I know it better, I can quickly solve the problem. But tomorrow somebody else in my team would taking up that role. So you need to have a alerting system which actually provides you a mechanism to schedule who need to be reached out when there is an incident or when there is a slowness observed on a specific application, and how to reach to that person, whether it is through an email or through an SMS or through calling a Slack or a Teams interface or to a WhatsApp message, a Telegram message. So all of those configurations the system need to provide, which is what typically PagerDuty or these kind of tools will allow you to configure and are making a call, right? So during the day, you might say, send me SMS, I'll take a look at it. But in the night, you don't wake up for SMS message. You might need a call to come onto your phone. So these tools do provide you mechanisms to configure that. So it is very important when you are dealing with a much complex system, you need appropriate parties to be having on the standby in case of a need, right? And that's what typically this PagerDuty or alerting systems will help you. And then you need to have some system which I talked about to basically, sorry. Right, so you need a system which basically allows you to do the bot protection, and you save the content and you share the content much faster. To give an example, if Amazon has thousands of products or Flipkart has thousands of products, we access the same content across different cities, different districts, different towns within India. So if the server is running in Chennai or in Mumbai, if you're accessing from Delhi, the speed at which the image gets rendered is going to be slower, and vice versa is going to happen as well. Right? That's why typically you need a local caching of the content of the image or any video, so that the content can get rendered onto your system faster. Same thing YouTube also will apply, because YouTube also has videos, streaming content. Even any social media platforms you typically see, they need to have content locally cached so that the content delivery can be faster and you don't incur, or even those network providers like Jio or Airtel doesn't incur too much of a cost. They typically cache the content. That typically Akamai provides that global caching, and they do have the mechanisms to protect your website from any bot attacks like DDoS or any other attack pattern vectors, right? It can be fine. So these are all typical examples of tools what you get to see in the CD area. So when you again enter into different industry, different organizations, you will see some part of a replacement for these tools with a different tools. So that's pretty much around CD. So we covered from uh, when it comes to the application development life cycle, we covered how the system is built, the CI process, how it is deployed, and what all mechanisms are keeping it in uh, checks and balances to keep your system monitored and information is logged, right? So that is pretty much predominantly what you have, two different areas. And then when it comes to third aspect of the DevOps itself is, we call it as site reliability engineering, right? So what is this site reliability engineering means? I've been giving a couple of examples during the initial discussions aspect of it. And how do you measure that, right? Is what typically SRE focuses on. So what we have to ensure as SRE is, it doesn't matter how the code is built, what type of language it is being used for building the application service. And it doesn't matter what type of database is used for storing the content. But to the end user, we need to provide scalable, reliable, and stable system where they can transact. If Google Pay or Phone Pay is lagging, it is deducting money from your account and it doesn't reach to the target party. And if it happens 10 out of 100 times you're accessing the system, you would stop using that application and go to a different application, right? Same thing would happen for any service. If WhatsApp doesn't deliver your messages consistently, you will end up using Telegram. If you're not able to watch reels on Instagram, you might end up using some other service. Could be TikTok, could be YouTube, shorts, all of them, right? So people have choices. People have multiple options to choose from, right? And multiple platforms they can interact with. So if you have a service which is not reliable, you would start losing customers to other beans, right? So that's why every company has this practice when they are running their services in a cloud operation. When it comes to B2B versus B2C, B2B might have lesser scale challenges because you're talking to business, right? One school talking to Byju's, the number of schools talking to Byju's would be in lakhs. But when you look at Amazon, B2C, business to customer, there are crores of people accessing their site. The scale requirements are going to be 10x, 20x, 100x compared to B2B businesses. That's why you need to have a solid practice that is being adopted in the system based on the reliability and scalability of a system, right? So that's why you typically get to hear this SRE, site reliability engineering, as a concept within DevOps domain itself, right? So key principles here, we basically do application monitoring, change management, reliability, right? So what is change management? Today I have a version 1 of application deployed. When version 2 gets deployed, which is basically with additional functionality, is it performing better than the previous one? Or is it performing worse than the previous one? There has to be measure for it. And if it is needing, it is performing okay, but if it needs 5 more servers or 50 more servers to perform for the same set of users like what version 1 is, those need to be measured as well, right? So all of this is what really SRE covers. And reliability is like how often the service is going for a restart because it is running into high CPU, high memory, which is not able to be given by the underlying system for you, right? So all of this is what really SRE's team's responsibilities falls under. So each application has few things, right? So what we always look at, one is SLI, service level indicators, right? So you need to have a mechanism to give to the application developers that your application is in general healthy or it has few problems, right? Let's take you have as an example I've given you. Your application is healthy, but there is one API taking more time. That is what really the SLO means. SLI means, sorry. Um, SLO is service level objective. You basically say if my service is 99% up, that means 99.9% up means my service is not going down quite frequently. If it is 99.99% up, that means in a given year, your application is down for 8 hours, which is also a bad thing. You go for 99.999%, that means your application is down for 8 minutes. That's why typically you would see SLO being talked about being a very high uptime need. And then when it is up also, it should function properly without any quality issues with one such API or a couple of APIs, right? Or errors rate is going up, right? All of this is basically what is covered as part of SLO. You keep measuring them and then you measure it, right? So what you typically do is you give a budget. Let's take it with 99.9%. The budget what is given is you can have maximum of 8 hours of problems in the entire year, right? Which is 365 days into 24 hours. You have only 8 hours where you can have trouble with your application. Be it with one API not functioning at a less than 2 milliseconds latency or 2 milliseconds execution. You can have probably 10 errors, less than 10 errors. That your application is down briefly. No application server component is running. Or you had a problem with database, all of it. If you look at all of those, is what I'm talking about, 8 hours. This is less than a 1/3 of a day in a 365 days, right? That is what SLO. So you give a budget, and whenever the problem happens, you keep removing, you keep deducting from the budget of 8 hours, and then you keep telling the application owners that you have 4 hours left. We were still in March, right? That means a very steep curve to look at the stability of your application in the next 8, 9 months or 10 months of this year, right? And SLA, which is basically when you look at a 99.99999, if I go to that level, you see 8 milliseconds, 800 milliseconds, or even 1 millisecond failure times, right? To achieve that kind of a functionality, that kind of high level availability, right? Your application need to be deployed with not 10 instances, you might need to deploy 100 instances to ensure that at least one instance of your application is running if you want to get to a higher nines. So when you design your applications, there are multiple parties involved in your company. What is going to be used in, right? So your business team or your marketing team, you have SLA agreement with them to say, from a tech side, I am going to ensure 99.9% uptime. When you're talking to B2C, which is your customers, or B2B, you tell them that you have occasional downtimes for maintaining quality of our application, or you have to upgrade your servers, you have to do something of your internal networking, all of that. You provide or you promise to the your business consumers that you will have a little bit of a downtime, right? You typically see if you own a bank account, bank sending messages to you, SMSs that on this day between 2 a.m. to 5 a.m. you would see some disruption of service when you are trying to withdraw money or when you're trying to do an online transaction using credit card and debit card. But when UPI don't know problems, that means they're upgrading some APIs which are actually going to be having problems in ATM interaction, which is one of the clients, or a credit card, which is one of the client for online transaction. But API is using a different set of API. So that API they're not upgrading. So those kind of things is what typically companies do to minimize their downtime. They don't do an entire service level outage, but they do only 1 or 2 types of services, which is a simple example I've given in the payment side, right? Again, this has come up from Google itself, with Google being very high throughput need, a very high system scale, because searches and other things what it does. And we are doing a Google Meet right now. You are about 200, 300 people on this call, and to have that SLA, they came up with this technologies to measure them for each service of the SLI is coming up, what SLO is, what SLA is. This is what SRE typically focuses on in a given organization. So these are basically what I've talked about in many examples. So availability is responsibility of SRE. Latency is the response times of each API. Performance is how your application is performing with number of concurrent users. And efficiency is how efficiently application is using your resources, how many CPUs are given, how efficiently the CPU is being consumed. Error handling, how application is handling errors. So one of the examples could be if you go to sites like Netflix, they give you content which is newly released. They have a recommendation service which gives you based on your past watch. It will tell you you can probably like this uh, content as well, right? When it comes to recommendation service, not able to handle the load. Netflix still loads the page with the new content. You won't see any recommendations coming up instead of failing and not even showing the content. Similar things you would observe on Amazon, Flipkart as well, where you would see some recommendations on the landing page. If the service is having a problem, you would see a simple new launches and some ads which are going up, but the promotions currently being running, right? So that's how they typically handle. You need to typically handle the errors that come up on your application side. Change management, who is deploying what version at what time, is it certified by the CI/CD process? All of that is basically SRE's responsibility. Real-time monitoring, incident response, capacity planning, peak load handling, failure scenario simulation, data analytics, and predictability. Right? When it comes to all of this, to give an example of these three areas, right? So when you look at in Flipkart or Amazon, you would see during uh, Dashra and Diwali, you would see a big billion day, or which is what typically Amazon runs, right? Or you have some similar promotions that are being run on Flipkart as well. During Holi, you might see a smaller promotion activity that is happening, right, on these websites, on these e-commerce websites. So you typically bucket them into a normal day promotion, and you have a specific festival type of equation. And then when it comes to Diwali, which is going to be a festival celebrated across India, and you typically end up buying a lot during that period. You might get bonus from your organization. That is typically the way a lot of companies do operate in India. When it comes to those days, the volume of users who are going to be transacting on these websites would be 3x to 5x or even 10x to 100x sometimes compared to normal days. So SRE's responsibility is to keep testing that your application indeed is going to scale to that need of 10x to 100x support. And you plan your systems to have the capacity reserved to support your application to scale when you launch iPhone or when you start your promotion for a big billion day, where you release a lot of products with 10% or 20% discount. Everybody is rushing to buy whatever they like, right? So those days when you want to get money quickly, you need to basically have your systems up and running, right? So if you go watch on the internet, Amazon, Flipkart doesn't come out with the numbers openly. If you look at 4 or 5 years back before COVID days, Alibaba is one of the e-commerce player in China. They used to talk about in the first second that they made $400 million commerce when they opened their website for what they call as level 11 single state. So they made like 400 million, 300 million is what they call it as. Like if you want to get 300 million, let's take even if you sell a phone of iPhone, which even if you take it as 1 lakh, you are actually running like almost like 800,000 or 80,000 phones need to be ordered by all customers in the first second itself to get 800 million, right? So that is what really the system is scaled to a level where it can handle obscene amount of traffic. And on a daily basis, you would find this situation with our ticketing system IRCTC. When there is a release of tickets 3 months from now for long distance trains, you would see a rush of people trying to book ahead in time. and Tatkal tickets, all of them, right? So you would see that rush is happening on these websites as well. So planning of capacity, peak load handling is typically part of your SRE as well. So when it comes to SRE, since there is a lot of these areas you cover, you have the same monitoring tool what is classified here, like Prometheus, Kibana, you end up using them as well in SRE role also. But when it comes to capacity planning, there are load runner tool, which is a paid tool from an organization. There are K6 scripts, so there are JMeter, all of these scripts you typically end up doing to simulate the load onto a system in preparation for your peak load. And you come up with the failure scenarios. You basically bring down a service, reduce the capacity of the service, and see how the system is behaving for error handling aspect of it. Is what really the SRE team keeps doing it. And based on the past patterns, or based on looking at the way the system is behaving, they predict, and we need to predict mechanism to we need to have predict mechanism to figure out the problems, and you end up adding more capacity in case of a need. That is what typically the SRE functions and rules are. Yeah. Yeah, so that basically covers most of it. And then today, if you look at on all of these, right, so the complexity of the system is growing, and your need for scale is growing, correct? In those cases, your cost of the infrastructure might run into millions of dollars, right? And even billions of dollars if you don't put a prudence of cost, right? So in the last 3-4 years, since a lot of new cloud providers are coming in, a lot of cloud services are being offered, cost management is becoming a biggest problem. You are seeing a new trend of role that is being introduced, which is basically not only just a CI engineer, a CD engineer, and even the financial prudence is being called out as a FinOps practice, which is basically taking shape right now. The people who have expertise on how the application is architected, how the application is deployed, how the application is scaled, which is a study role, are actually contributing to the finance practices also to ensure that the cost of the system is managed properly. Yeah, that is where you would see this new area showing up in the area of DevOps itself, which is called FinOps. Yeah, but the general things when you're coming out of your college, what you can expect from a career option perspective. So if you look at from a DevOps engineer, so you are basically going to be developing build systems for Python, Golang, Java, Rust, and one of those programming languages. So you need to understand how to integrate some of these build components with the Jenkins or to any other tool like Argo CD, or come up with any sort of other framework to do all of this. So you might get exposed, and you end up writing your scripting in on these pipelines, either using Java or any of these languages, typically a Python. Anything can be used as a programming interface for automating some of the builds. But the amount of code you would be developing might not be at the same level of lines of code like any developer, but the functionality, what you need to ensure from it, scalability, all of that is basically ensured as well, right? So this is one aspect of the DevOps engineer. And CI/CD pipeline development. So these tools typically have a lot of things which are pre-built in plugins which are available. You need to integrate with those plugins and the code what you have developed using these languages. You integrate them and then basically build your pipeline. And then application system performance and alerting is what really you would pick up a lot of tools to do the integration with your application, like as I mentioned, Prometheus, and a tool like PagerDuty. All of them you need to understand in depth. And how do you monitor, how do you configure the systems? So more than the development, you need to understand the nature of the application. You need to go in depth with each of the Java container or a Python application, how it behaves, how do you measure, how do you monitor those systems, right? Is what really you need to kind of ensure. And then the distributed computing, which is what I mentioned about when your application concurrent user count changes. You are distributing your workload across not only a single region, multiple regions, and your code is basically not a single service but multiple microservices. All of this need to be uh, thought through, and you need to have mechanisms to build that scalability into the system as well for the distributed computing and cloud computing knowledge. So, which I mentioned about Google Cloud Provider, GCP, or AWS, Amazon AWS, or Azure, is what you typically end up putting your hands around. An operating system like Linux, you need to typically, that is what really most of the people today use, not Windows, unless there is a specific service that need to run on Windows. We end up using Linux as a operating system to run any application what we developed in Python or Golang, all of them, right? So this is where you get depth into the operating system as well, and the tools what we talked about, SRE and all of that, troubleshooting and debugging. Because when you're getting into a situation, it's not that you look at application logs alone. The system level, how the data transfer is happening, you might have learned TCP/IP, layers of communication. You might put in some proxies, you might put in some security checks around each of the layers in level 1, level 2, level 3, levels other services, right? So of your TCP stack itself. So those things is what typically you end up debugging when it comes to your application and the DevOps side aspect of it. And problem solving is typically when you are thrown a problem that I need to run my application with thousands of instances. You need to come up with a solution, right? You cannot be provisioning 1,000 servers manually, right? So that's why the cloud providers have come in with APIs. But how do you use those APIs, or how do you build a new automation on top of the existing APIs to make this process smoother, right? Is what typically the challenge is what we face on a day-to-day basis when you are operating as a DevOps engineer. This is a high demanding role when it comes to the thought process and the number of tools you need to research. And the way you need to research is how do you adopt it quickly and how do you make it easy to use for developers or any quality assurance teams is what really the challenge of a DevOps team typically be. Yeah. This is one of the area. And then another area you typically get to hear is a database administration. So since you've seen applications are built using heterogeneous databases like Postgres, Oracle, MySQL, Mongo, all of this, you need to manage these databases for supporting millions of transactions in a minute or a second, right? How does the system behave? So each of these administrators would need to understand in-depth functional aspect of each of these component and configure these servers with appropriate CPU memory configuration. And then the data layout, how do you distribute the data on the physical system so that one table scan or one index scan doesn't stop other index being scanned from the same disk, right? So physical layout of the data, logical layout of the data, how do you partition the content so that the queries look at a smaller section of the data, not the entire data in the table. How do you manage indexes to faster querying? How do you optimize the queries? You would have learned all these options like normal forms, different normal forms in your SQL course. So this one of the functions of DB administrator is to ensure apply those techniques to scale your database for a lot of transactions which are happening in concurrently, and that provide the consistency of the data. And you end up reviewing the SQLs which are being actually developed by the application users when they hit the database, and you sometimes review or end up writing some PL/SQL code, a procedural code into the databases also. Database upgrade, because each of this application like Postgres, Mongo, Oracle, they do release new versions of their software quite often. You have to come up with a strategy for upgrade of your database, which is running with terabytes of data. All of that is basically a necessity of your DBA role. And then I briefly touched upon backup and restore. You need to have a backup for your database typically, and then you need to have strategies of restoration of the data and everything. And the database tuning with the logical table design index I've already covered. Distributed computing knowledge. Now your database is not going to be hit from one instance of application. There are going to be hundreds of instances running. So how do you manage that? And then you have to integrate your database with the same DevOps SRE tools so that the monitoring can happen in a common manner. And you troubleshoot your slowness queries, you troubleshoot your index needs, all of that, and the problem solving. As I said, if thousands of applications that are running to interact with your database, how do you solve the problem? How do you communicate with each party in this company is what typically the career options of a DBA are. Yeah. And security engineer is another area. What I briefly covered about static code analysis to find out if your code is following a practice where you end up leaking more information. And you need to do operating system vulnerability tracking because you would start seeing people finding out vulnerabilities within the operating system and using it, though your application code is clean. And API level security checks. Your API might have not sanitized the data, or it is leaking more information, or it is not doing the session validation. Perimeter penetration test. Basically, you try to penetrate from outside and see if I can leak any information, if I can fetch any information, or you try to simulate a DDoS attack and how your system is built for it is what typically. And then there are some actors who are going to be using in a manner where they try to find multiple ways or hops to get to do a fraud. So this is what security engineers' constant job is to figure out that any deviation from the logging or any deviation from your users' behavior is typically they trap it with the different rules being configured in the system to find out the bad actors in the system, and we block them or we find out ways to block them is what typically the security engineers aspect of it is. When you're adapting to any new tool, how the tool is being internally, does it have any vulnerabilities where it is leaking information to some third-party website where it is going to be a headache for us to manage, right? So all of this is basically the security engineer's role, right? So they're going to be part of CI, as well as CD, and then they do their own activity outside the CD as well to keep ensuring that perimeter is always protected. You don't open up a port which is not supposed to be open to public. So all of those things is what typically security engineers' job is. Yeah. And the SRE I talked about, configuring monitors and configure channels to alert people, coming up documentation to resolve the alerts in different conditions, and first responders in case of production incident. And once incident is resolved, you come up with the root cause and then try to come up with strategies to prevent it. It's not just you always respond to the monitors or whatever it is, right? So that's what predominantly. And then FinOps I talked about briefly. There's a new role coming up, so where you look at the financial prudence, how you end up using your cloud services, how do you optimize the resources, how do you plan your capacity in your data center, how do you reutilize the existing hardware, software components to avoid cost runaway is what typically the FinOps practices career role right now looks like. So when you're coming out of college, you do have options to start from any one of these areas: DevOps, DBA, security engineer, or SRE, or B2B, FinOps guy. All of that is what really the career options are in front of you. But this area itself is basically very vast because of the tools that are coming out to ease your different operations needs like CI/CD and even security vulnerabilities, all of it. And even the life is becoming tough for some of us because people are finding ways to hack into your system. So how do you keep yourself up to date with a lot of new technology components and a lot of new challenges which you guys face with the day-to-day? Because the scale of data that is needed for AI to be trained has been humongous in the last few years. DevOps engineers constantly face challenges to manage the huge amounts of data, plus the support need for modeling and uh, even training purposes, right? So all of that is basically the new technology, the invention that basically push uh, other community people to like developer community and QA community to uh, be better at their day-to-day affair, actually puts in bigger challenge in DevOps to make sure that we provide the underlying framework or infrastructure for development and QA teams to succeed, as well as a business to succeed. It provide the security foundation. It provide the scalability foundation is what really the typical role of a DevOps or a DBA or whatever you call it as in this area itself, right? That's where you would see my presentation end. Any questions you guys have? You can chat. You can put in the chat right now. Absolutely no questions. Okay. So typically when it comes to SRE, as explained, right? So you would be being the first responders. You might people typically call this terminology called on call. On call is basically you are supposed to be receiving the calls or getting the calls from any one of the monitoring systems, so that you get to see get to hear. When it comes to these roles, right? So NOC, if you're getting an offer from NOC perspective, that means you are not a technical uh, person in the job. You are taking the calls as a first responder. You would not know how to resolve the, or not know how to look at the alert as well. Your responsibility in the NOC typically is to reach out to SRE, right? So that's why you need to be extremely cautious about what is the type of job that you are getting into, uh, whether you want a technical or non-technical job. That's why understanding these terminologies does is important for you to make a career choice when it comes to choosing what you want to really get into as a job aspect. Yeah, yeah, I hope that clarifies things. So if there is no questions, we can end the call right now. Otherwise, I'm here for the next 15-20 minutes for taking any questions from you. Okay, thank you then. Okay, then. Thank you. See you guys. All the best. If you do have questions, bye bye.